Hello and welcome to the Encore Research Group podcast, where we encourage community research and education with weekly podcasts. I'm your host, Benton Loeyball, and this week we're talking about how high blood sugar can slow your stomach. What is diabetic gastroparesis, and how does diabetes affect digestion? Diabetes is a widespread disease where the body cannot process sugars effectively. It has myriad effects on the body, including in the gut. Diabetes affects nearly every part of the gastrointestinal tract, from the throat to the anus. Diabetes is one of the most common causes of a condition called gastroparesis. Gastroparesis is from the Greek language. Gastro means stomach. Paresis indicates a partial paralysis, so gastroparesis means a partial paralysis of the stomach. It empties food slowly. This condition is more likely to affect women than men, but there aren't good numbers on how many people it affects in total. Symptoms of diabetes and gastroparesis may overlap, but include feeling full, weight changes, nausea, vomiting, bloating, and diarrhea. Gastroparesis can lead to serious complications like malnutrition, decreased quality of life, including anxiety and depression, and significantly higher mortality. The effects of diabetes further exacerbate these complications. How diabetes actually affects the stomach muscles is complex and fascinating. The digestive tract is lined with smooth muscle. Smooth muscle isn't connected to bone and contracts in long, slow, low-energy waves. This is great for contracting blood vessels or moving food through the stomach and intestines. These are involuntary muscles, meaning we can't consciously control them. In fact, the brain modulates activity of the gastrointestinal muscle, but it's controlled by our little brain in the intestines. This little brain is made of around 500 million neurons and is called the enteric nervous system. The enteric nervous system is a distributed brain-like bunch of neurons and other cells spread throughout our abdomen that may be able to act independently of our big brain. It is responsible for getting smooth muscle to contract rhythmically and in response to food. The enteric nervous system also includes cells that are not neurons. An important type is interstitial cells of Cajal. These are pacemaker cells that regularly generate electrical signals to coordinate muscle. The prominent players in the enteric nervous system, however, are neurons. Though neurons are electric, they communicate with other neurons by releasing neurotransmitters and receiving them in specialized receptors. These are often the same neurotransmitters we find in the brain, though they may have different functions. Dopamine is a great example. In the brain, dopamine receptors are part of the reward pathway, giving you feelings of pleasure and motivation. In the enteric nervous system, dopamine receptors act to suppress muscle movement. More dopamine in the brain makes you feel happy, but more dopamine in the gut restricts the movement of food. In diabetes, this can get all messed up. A key aspect of uncontrolled diabetes is the inability of the body to regulate blood sugar. This causes a few significant disturbances. Primary among these is neuron damage. Since the affective neurons are involuntary, we call this autonomic neuropathy. Autonomic neuropathy in the gastrointestinal tract can take the form of fewer neurons and ones that can't communicate well because of damage. Diabetes can also lead to changes in the signaling pathways of smooth muscle and may destroy some of the pacemaking interstitial cells of Cajal. Together, these changes result in fewer smooth muscle contractions and a slower flow of food through the stomach and intestinal tract. The slow flow of food in gastroparesis can cause a feedback loop. Slow food is more likely to be mistaken for invaders, potentially causing inflammation. Even worse, the extra time in the digestive tract means there's more time for glucose, a major sugar, to get absorbed, increasing blood sugar and making the symptoms of diabetes worse. So what can be done with diabetic gastroparesis? The first step is lifestyle alteration. Smaller and more frequent meals may help alleviate symptoms. Increasing non-carbonated liquids and decreasing fat and fiber may also help. Monitoring nutrient levels and electrolytes is critical. Beyond this, few medications are currently available. The most prominent are dopamine D2 receptor antagonists, meaning they inhibit the effect of dopamine. Metoclopramide inhibits dopamine and mimics serotonin. It is effective at increasing the speed of emptying. It can cross the blood-brain barrier, however, causing unintended side effects in the brain. Domperidone is another dopamine receptor antagonist. It does not cross into the brain, but can affect the heart, slowing the time it takes to recharge between beats. This medication is not approved in the United States, though it's been approved in several other countries for decades. Clinical research is currently looking into new medications that may provide the same dopamine receptor inhibition as metoclopramide and domperidone, but without the ability to affect the brain or heart. With the help of clinical volunteers, diabetic gastroparesis may pass quicker than we expected.